So now in this video, we will be taking a look at how to apply sine rule to help us answer questions with regards to triangles itself. So remember, our objective is simply to find unknown angles and unknown lengths. Now the first case where you can apply the sine rule effectively is when they give you two angles and one side. So two angles and one side. So the moment you have two angles and one side, definitely you can find um, all other sides itself. You can actually use sine rule itself. So let's take a look at the question. So in triangle ABC, AC equals to 9 cm, angle BAC equals to 56 degrees, and angle ACB equals to 23 degrees. Find the sides BC and AB. So if there's no diagram, again, in any geometric questions, if there's no diagram, always draw a simple diagram. Doesn't have to be accurate, but as long as you know the positions. Okay, the important part is the position itself. So let's just label this ABC. Okay, then we say that AC is 9 cm, so this is 9 cm. Angle BAC is 56 degrees, so this is 56 degrees. And angle ACB is 23 degrees. Okay, now a quick recap. The sine rule states that I have the length and the angle that corresponds to, which is opposite of it. Okay, the fraction, the ratio is always the same. Okay, so this is our sine rule itself. Okay, so how can we apply this? So what this means is that this angle, this length over here will correspond with this angle over here. Okay, so this length corresponds to this angle. This length over here will correspond with this angle over here, and this length over here BC will correspond to the angle opposite, which is 56 degrees. So the only known length we have is 9 cm. So it will probably help us if we can find this angle ABC first. So our working will be angle ABC equals to 180 degrees minus 23 degrees minus 56 degrees, which is equals to 101 degrees. Okay, now just a quick recap. This is of course because of sum of angles in triangle. Again, not needed to write down the reason here, but I thought it would be a good time to actually recap this itself. Okay, so now we know that this 101 degrees. Again, you can see our diagram is not really accurate, but it's okay. Okay, so now we know for a fact that, let's say I want to find BC first. So we know that BC over sine of the angle opposite it, so sine 56 is equals to, so the length that we know is AC, and the angle we know is sine ABC over here. Okay, maybe it will be good if you can label this angle over here. Oops. Okay, let's label the angle lah. So this BC corresponds to sine angle BAC, and AC over sine angle ABC. Okay, and then we can sub in all the numbers. So BC over sine 101, sine 56 is equals to AC, which is 9 over sine 101 degrees. Okay, and then to find BC, we can just multiply sine 56 throughout. So we have BC equals to 9 over sine 101 multiplied by sine 56. And BC is equals to 7.6007.6010 cm, and of course leave it in three significant figures. BC equals to 7.60 cm. All right, so that's how we can use sine rule to find the unknown length. Okay, we can do the same thing to find AB. Okay, so AB is opposite of angle ACB, so we do the same thing. So we always write down what we want to find on the left hand side. So AB over sine of the corresponding angle, sine angle ACB, okay, equals to Then whatever that we know is on the right hand side, so AC over sine angle ABC. Okay, you can also use BC and sine BAC. You should get back the same answer. Okay, but I prefer to use what is given to me also, because it will help you eliminate careless errors. So AB over sine ACB is 23 degrees equals to AC, which is 9 over sine 101. So to find AB, I just multiply by sine 23 to out. So I have 9 over sine 101 multiplied by sine 23. So AB equals to 3.5824 cm, and round off to three significant figures. AB equals to 3.58 cm. Okay, so that's how you can actually use sine rule to solve for unknown lengths itself. Okay, solve for find unknown lengths. Alright, so in the next video, we will take a look at another case. So instead of finding unknown lengths, we can actually use it to find unknown angles as well. Okay, so look out for the next video.